You can see all this?
Yeah,
Oh, okay.
never mind.
Okay, darken it up. Okay, this basically says, okay, are you with me? Guys, we're going to jump on what we call a unit circle today. It's called a unit circle, but it's not going to be introduced for a couple more slides. But right now, I'm going to say this to you. I'm on this circle somewhere, right here at this point. I'm going to call this point what? XY. XY, that's what I'm calling it. Okay, well that would mean on this point can create a triangle if I go this way, and I go this way, and I come right back to the origin. Now each side of the triangle is given a number. This number right here, how far did I travel from the origin to here? I traveled X. It's right there. I traveled what here?
Y.
Y. Now this is known as the what? It's a circle from the center to the edge of the circle.
Radius.
Radius, R. So we're going to talk like this now. We're not going to say opposite, adjacent, hypotenuse. You know what we're going to say? XYR, yeah. So now, here's theta, right here between the terminal side and the x-axis. Theta's right there. I'm going to ask you the question again. I know you guys are going to tell me sine of theta is opposite over hypotenuse. I don't want it. I want these numbers. So what is sine of theta? Y over R, because opposite over hypotenuse would be this side Y over the hypotenuse R. So there's a new way to talk about sine of theta. It's Y over R. So fill the rest in. What's cosine of theta? What's tangent of theta? Shouldn't be very difficult. And you said cosine of theta is what, Chris? X over R, he's right. Tangent of theta, Megan, is what? Say it again, Molly. Y over X, yeah. You know, when I hear tangent, I think opposite over adjacent. What's opposite? Y. What's adjacent? X. Y over X. Okay? That's where that's coming from. Okay? Fill those three in. Cosecant, secant, cotangent, fill it in. What do you think it is? Shouldn't be very difficult. Why shouldn't it be very difficult? You guys are saying because it's just opposite. It's not opposite. It's reciprocal. So this one's what? R over Y. Reciprocal to sine is cosecant. Reciprocal to cosine is secant. What's this? R over X. Cotangent. X over Y. Yeah?
Yeah.
Okay. Now this is how you have to think in lesson 4.2. And actually, from here on out, because everything you're going to be asked to do is find sine of this. Well, you got to think, well, sine is just y over the radius. That's all it is. Cosine is x over the radius. Okay? Now, we go into this. Now they throw it at you. It's the what? Unit circle. Okay? You're going to talk about the unit circle. And don't read this right now, but the unit circle simply does this. They make your radius always equal to what? Equals 1. Okay, so guys, from here to here is how far? 1. Which also means now, remember that point x comma y? What's this radius going to be? 1, because the unit circle says make it 1. Okay, well then this is still going to be what? This side is what? Y. This side is what? X. Okay, so now let's try this again. What's sine of theta now? Emma, what is sine of theta?
Sorry, I can't read it.
You can't read it? Sorry. Okay. Is it the green that gets you?
Yeah, maybe. I just have that.
Okay, so here is theta, come on over, look at the opposite. Y over what? Y over 1. So on the unit circle, what sign? It's really just y. If you know the y value, you know sine of theta. You don't have to say over 1 because over 1 doesn't matter. How about cosine? X over 1. Or just what? X. Good? Okay. Tangent. What's tangent of theta, Zach?
Y over X.
He says y over x. Yes? Okay, keep going. No, there isn't. No, I'm going to leave it. I'm sorry. That's good. Okay. Now, there is something, right there. Where do the approximations come from? Okay, first of all, approximations around the circle happen all the time. You use your calculator all the time, unless what? It says right here, approximations, any angle other than the multiples of this, 30, 45, 60, and what we call quadrantals. What are quadrantals? They're the angles that fall where? On the x-axis or the y-axis. You guys, anytime I give you multiples of these or any of these quadrantals, you can do it in your head, and I will expect you to do it in your head. Approximations come from like 35 degrees, 52 degrees, like that. You're not going to do that in your head. You'll just do these. And by the way, multiples would be like 30, 60, 90, 120, 150, 210. These are all the ones you'll do in your head, okay? But let's just do 0 degrees. Let's just talk about 0. What is sine of 0 degrees? Well, we know sine is y over what? On the unit circle, 1. Okay. So where's 0 degrees? It's I'm going to do a different color. 0 degrees is right here, isn't it? Oh, I landed right on the circle. What's the ordered pair? What's the ordered pair right there? And you knew it was 1, 0 because the radius is always 1 on the unit circle. Now, I did tell you you'll have to do these in your head. I'm just going to do this one with you right now. What's sine of 0? Well, sine of 0 is y over 1. Which one's y? This is x. This is y. You put what here? 0 over 1. Y over r. Okay, answer's what? 0. Sine of 0 is 0. Hey, think of it. What's your y value? What's your y value right there on the x-axis? 0. Okay. Cosine is 0. What's cosine? Well, isn't it just x over what? It is x over r, but it's 1. The radius is 1, so it's just x. Okay, look at 0. It's x over 1, but look at your x value. It's 1. So it's 1 over 1. Oh, guess what? The answer is 1. Good? What's tangent at 0? What are you going to put? You're going to put y over x, aren't you? Oh, well, which one's y? Yeah, this is y, so it's 0 over what? 1, but that turns out to be 0. Here's the answers. Oh, I got one more. What's cotangent of 0 degrees? That's going to be what over what? X over y. Better yet, flip this, 1 over 0. Answer? Hey, guess what? There is no answer. It's undefined. Do you know that we're going to graph all these? So if you graph cotangent, and you plug in what? 0 degrees, you get that answer. There's no answer at 0. So on a graph, if you're coming towards 0 degrees, what's going to happen right at that point? You're going to run into no answer, so what's going to happen? It's going to go what? It's going to go up, 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 It's a vertical asymptote. Or you might go down. I don't know which way you're going to go because I don't really know the function. But when you get undefined answers, you ran into an asymptote, you're going to go whoop, like this, or you're going to go straight down. And that's what happens every time you get undefined. Okay? Certain functions are undefined. Cotangent will be undefined sometimes. When that zero pops in where? On the bottom. If zero's on the top, you get an answer. It's what? It's 0. Okay. Oh, here's a quick note. Just a quick note about your book. Your book in 4-2 does this. When you, instead of saying theta, they replace theta with t. So in lesson 4-2, all of a sudden they start talking about this. T, which represents the corresponding distance on the circle, usually measured in radians. So what they say is this. This is t right here. It's the distance from here to here.
It's arc length.
It's arc length. But you know what? It's also what? It's theta measured in what? Radians. So really, isn't this what a radian is? A radian is take your radius and wrap it around the circle. So your radians is a distance. And really, guys, if I'm you, theta and t are the same thing. So when you see something like this today, you might see this. Cosine of t. No.
Cosine of theta.
Just cosine of theta. Just get rid of it and go like this today. Anytime you work your homework today and you see t, throw it out the window. It's because t is the distance from here to here, which is a radian measure. Okay? Just do that, please. That's all this slide is for. There's not much teaching going on there. Okay. Here is sine, here is cosine. I don't think I put that on the top of your paper today.
Nope.
So you should do this. Okay, if you are graphing, this is graphing sine and cosine, I need to know a couple things. What's the domain, what's the range, and what's the period of these functions? Well, come over here and go like this. Draw yourself a unit circle. Go like this. And you know the radius is 1. So this point right there is what? 1, 0. This point at 90 is 0, 1. This point at 180 is? -1, 0. Yep. At 270? 0, -1. Okay. Look at the domain. Remember the domain, it's what you can put in. It's your x value, right? So what can I put in for theta? Can I put in 0 radians? Can I take sine of 0? Didn't I just do this? Sine of 0? Yeah, I got answers. Okay, can I put in this, any of these things? Up to pi over 2? Can I put in pi? Anything here? I mean, I can keep doing this, can't I? So what is it?
-1 to 1. X is greater than -1 less.
No. Can I put in 2 pi? Yep. 4 pi? 12 pi?
All of the above.
Yeah, I can put in anything. Anything goes in. I get answers for everything. So will sine or cosine have vertical asymptotes? No, I just told you. You can put in a number and you'll get a number back. So there's no vertical asymptotes with sine and cosine. Okay. Range. What's the range? Well, that would be the y values. Now you're limited. You are limited. What's your limit? The highest you'll ever go is what? 1, your y values. The lowest you'll ever go is what? Yeah. You will never get bigger than 1, and you will never get smaller than -1. So your y's will fluctuate between 1 and -1. You guys remember the graph? Yeah, it's the wave. Yeah, the height of the wave goes up to 1, then it goes down to what? -1. 1, -1. That's what it looks like. We'll do it in a week. Period. How often does sine and cosine repeat itself? 360. Okay. Watch this. Look at you put in 0 degrees, you get out what y value? 0. Then you get y values to go up here. You're positive. You're still positive. Oh, now your y's are what? Oh, now they went back to positive. So when did it start repeating? No, it took a complete circle to repeat. So you are right, Emma, you said 360, but I'm gonna say what? Okay? You will start repeating all your answers after you make a complete circle. 2 pi. Did you remember that from last year? Sorry?
Nope.
No? Okay. Well, no, you. Okay. It says we will find exact values of most trig ratios. Think you're what? Okay, I think I put that in this morning. Okay, so here's the deal. I gave you all these angles, but you know, like if you look at this point on the circle, right there, and you come straight down, hit the x-axis, go right back to the origin. Okay, that's a 30-degree angle right here. What's this point?
5/6.
What is it?
5/6. Right?
Well, no, this is x,
Yeah.
this is y. How did I get to this point on the circle? I went this far. And I went this far, right? Okay, nobody's talking.
Square root of
Yes,
3.
sir.
So, it would be square root of 3, 1.
Over 1?
No.
Oh,
square root
comma
of
1? Like this?
Yes.
Uh,
They have it backwards.
well, you're saying, I think you're saying this. This is 1.
Yeah.
This is what?
2.
2. This is the square root of 3.
Yes.
That's what you did?
Yes, that's
Square root of
my
3, 1.
base.
Oh, okay, now I see what you did. Okay. Do you guys remember from your previous slide that the x value is really just what? And the y value is really just what? X is cosine of theta, right? Comma, what's y?
Sine of theta.
Sine of theta. Do you remember from your previous slide? I'll go back. I'll try to prove with you. Let me go back. I'm back again. Right here. Sine of theta, or y. Y is what? Sine of theta. X is what? Cosine of theta. So guys, if you want to know where you're at on a circle like this, go do this. What's the x? And what's the y? Well, what's cosine of 30 degrees?
0.866.
Wait. Cosine of 30 degrees is what?
0.866.
Yeah, oh, you're using your calculator. Square root of 3 over what? 2. So if you'd have said this, Zach, I'd have been a little more happy. Okay. And then what's sine of 30 degrees? 1 over 2, 1. This would be for the unit circle. Okay, the unit circle is where you're getting that from. So that would mean the radius is what here? How far out? 1. So this is also 1, but I made it a 2. And I'm making it a 2 for a reason. I think it's easier for us to put our special triangle down and just understand x is what? Cosine of theta. Y is what? Sine of theta. And then if we just simply do that on a 30 and that on a 30, we get the ordered pair. And it does work, because if this was the unit circle and this is 1, do you guys realize 30 is just half of your radius? What's half of 1? 1/2. It works. I prefer that you guys do it that way. Now, period 5 wanted me to work with the number 1 right here, and I said that gets messy. And some of them said, I want to do it that way. And I said, fine, do it that way. Use this as a 1. This would be a half. And this would be half square root of 3. But I think that's messy. So, you guys see that point right there? Square root of 3, 2, comma, 1/2. Guess what? They repeat. See that 30-degree angle? It's right here. It's right here again. There's a 30. There's your right. Anybody know this point right there on the circle?
Negative square root of 3 over 2, 1 over 2.
Okay. You know what? What that means to me is every time you draw a triangle on your circle, you got to understand this leg is not the square root of 3. It's not the square root of 3. It's what?
Negative square root.
Yeah. So guys, your legs can be negative on a circle. If you went backwards, it's negative. If you go up, it's what? It's positive. So this is 30. This is 1. The radius is what? 2. I'm going to tell you the radius is always going to be what? Positive. I don't care if you're down here, your radius is always positive, okay? That makes sense? So guys, you know, this is 150. 210 is about right here. This circle is way off. This is terrible. This was supposed to match up directly below, but it did not. Anyways, this is still 30 degrees, and this is 60, right? So this is still a negative leg. What's this leg here? That's negative 1. That's a 2. So again, what's this point? It's really just cosine, comma, sine. What's cosine of 210? Yeah, it's negative square root of 3 over 2. Comma, what's sine of 210? Yeah, negative 1/2. Look at your ordered pairs. In quadrant 3, everything's negative, negative. In quadrant 4, just do this. Just make another one. What's your leg here? Square root of 3. What's your leg here? Now it's negative 1. Your hypotenuse or your radius is always positive. What's this ordered pair right here? Square root of 3 over 2 and 1/2 negative. Now I could do a bunch more, but that's really all you have to do. And you do need to remember this. I think you should maybe make one more for yourself and do the 45. 45 would be like this. Okay, there's a 45. And actually, this angle that I just drew you guys is how much? How far did I go? Well, I went in, I'm at 315, right? This is a 315 degree angle. But where am I on the circle right now? Remember, your legs are what? That's a 45.
7.
Isn't it 1, 1? Your legs are 1, negative 1. What's the hypotenuse? Square root of 2. Right? So what's your x value? Cosine of 315. Sine of what? 315. Well, look at your triangle. What is it? What's cosine going to be? Negative 1. No, cosine will be positive 1. Positive 1 over the square root of 2, which ends up being what?
Square root of 2.
Yeah. What's the y value? Negative square root of 2 over 2. Same thing, isn't it? Use your special triangles and things get easy. The unit circle, are you listening? Because sometimes I know you're tuning out. Listen, unit circle will only be used when you land on the x-axis or the, so give me an angle that lands here. 180, 270, 90, give me radians. Pi over 2. Half pi and pi over 2, same thing. 3 pi over 2, yep. So guys, how about 2 pi?
Yeah.
How about 7 pi?
Yeah.
Yeah, it lands right on the x-axis. Okay, actually it's over there. So, oh, reference angles. You gotta know what reference angles are. By the way, I was already doing it with you, and you didn't even know I was doing it. Okay, what's a reference angle? Found between what? The terminal side and the what? X-axis. So guys, if I told you right now, would you just graph me a 150 right now? Take that picture, graph a 150. I did it. I got my 150 in. Okay. But where's the reference angle? I see no right triangle, do you?
Make one.
Make one. Make what? It's a reference angle. A reference angle is the right triangle. So what are we gonna do here? We start on the terminal side, that's this side, and we jump on the circle, come where? Straight down to the x-axis. And back to what? Origin. Bingo, that's it. So what's the reference here, guys? It's right there. What is it?
30 degrees.
30, which tells me to put what numbers? Radius 2. Opposite of 30. 1. Opposite of 60. Yeah. But, make this like what? Negative square root of 3, right? Your legs can be negative on the circle, the unit circle, okay? Just remember that. You can have negative legs. Backwards is negative, and down would be negative, okay? Okay, do it again. Draw yourself a 240. Draw yourself a 240. See what happens. And then give me the reference angle.
On the next slide.
Well, I'm staying on this one. I know it gets a little messy. I'm sorry. 240 starts here, goes all the way to 180. How much more do I go? Looks like about that far. That is a 240. Got it? But that is not what you're going to look at. When you actually are asked to find sine, cosine, cosecant, secant, you're going to go get yourself a triangle. It's the reference angle found between the terminal side and what? The x-axis back to what? The origin. Do you see your right triangle now? Okay, this is the reference angle. What is this number?
60.
Yeah, you're at 60, which means this is a 30. Opposite of 60 will be what? Negative square root of 3. Opposite of 30 will be what? Negative 1. Hypotenuse will be what? 2. Hey guys, anything in this quadrant, your leg is negative, negative. Anything in this quadrant, your leg is negative, positive. Everything here is what? Positive, positive. And this one is positive, negative, which matters. Because sometimes tangent is positive, sometimes cosine is negative. You know, it just matters. Okay, let's keep going. We do it again. One more time. Do it in radians though. Everybody just quick graph this one. Negative 7 fourths pi. No. Change it. Graph that one. Graph negative 9 fourths pi. And then once you graph it, tell me the reference angle. I guess the one thing I want to know is what quadrant did you land in? Howard, which quadrant did you land in?
4.
He landed in 4. Did you land in 4? In between? In between 3 and 4? That would be the y-axis. Oh. Okay. Well, guys, do you guys realize that this is really just, turn that into a mixed number. That's just negative 2 and 4th pi, right? What's negative 2 pi look like? One circle. Boom. That's negative 2 pi. So guess what? I already took care of this. I just have to go what? A fourth of a pi. Well, these numbers are broken in. Remember, pi is half a circle. So do you realize that all I have to do is go this much further? That'd be another fourth. These are fourths. 1/4 pi, 2/4 pi, 3/4 pi, 4/4 pi. Okay, so you should have ended up right here. There's your terminal, and there's your initial. What's your reference angle? Pi over 4. Yeah, it's pi over 4, which is really a what? It's a 45. Okay, draw yourself the reference. It's like this. Back to here. You have a 45. What are your legs here? 1, -1, square root of 2. And of course, you could answer any question. What if I wanted sine and cosine and tangent? You'd answer it. You'll see. We're gonna do it next. Does that bug you? That force, not 2 in the fourth? You got to think. Okay, force. This is 1/4, 2 fourths, 3 fourths, 4 fourths, 5 fourths, 6 fourths, 7 fourths. I did that wrong. I ended up. I don't know how I got off, but I got off. Oh, I skipped this one. 6 fourths, 7 fourths, 8 fourths. Okay, count by fourths. A fourth of a pi. And a fourth of a pi. Pi is right here. Pi is not a complete circle. It's a half a circle. Okay. All right. Oh, here come the quadrantals. This is important. The quadrantals are simply going to be when you land on the x-axis at 0 degrees, or the y-axis 90. We're back on the x 180, 270, and you can go back to 360, but 360 is just 0. Give it to me in radians. What's 0 degrees in radians? No. You have already made a complete circle. 0 degrees is, I haven't moved. How many radians? 0 radians, 0 degrees, same thing. 90 is what? Pi over 2. 180. 270. All right. Now, if I did make a complete circle, it would be 2 pi, but then it went back to 0 again, so I'm repeating. Okay, so here's the deal. This is the only time I ever use the unit circle. Right here, when I land where? Right on the x or y axis. Okay, so if that's true, look. From there to there, what's the radius? 1. Unit circle. What's the ordered pair? 1, comma what? 0. If I land on 90, what's the ordered pair? 0, 1. If I land on pi, or 180, 1, 0. And if I land on 270? Okay. So now, would you please look at this and repeat what you've already done? What is sine of theta? Here's theta. Okay. Here's that point on your circle. Here's your x. Here's your y. And your radius is 1. Tell me what sine of theta is. It's what? Y over 1. Oh, well that's just y. So when you talk about the unit circle on the quadrantals, what's sine? Sine is y. Whatever y is, okay? What about cosine? Cosine is adjacent x over what? Over the radius. 1. Okay, well that's just x. Oh, cosine's x? Oh, cool. That's how easy that is. Okay, tangent? What's tangent? That is y over x. Okay, so that one gets a little weird, but the other two are nice. Okay, so now here's what I want you to do. Would you now try to find sine of 90? What is sine of 90? You should know sine is just y over what? 1. So it's just y. Look at your 90. Which one's y? This one or this one? Read the second one. Sine of 90 is 1. Cosine of 3 pi over 2. Cosine is really just x over 1. Which one's x? 0. Keep going. What's tangent at 0? Tangent is y over x. So your y value at 0 is right here. Here's y. Here's x. So it's 0 over 1, which is 0. Good. Try one more. Just one more. Ready? Would you do this one? Cosecant of negative pi. What's cosecant of negative pi? Cosecant is the reciprocal to which one? Sine. Oh, if that's true, then I should know the answer will be not y over 1, but what? 1 over y. At negative pi, where are you, by the way? This way. Okay, which one am I looking for? I'm looking for y. Which one's y? 0. Right here. What's the answer? Undefined. Okay, cosecant at negative pi is undefined. Yeah? Okay. So when do I ever use this unit circle? Quadrantals. 0, 90, 180, 270, back to 360, or radians. Okay. Is your hand up?
Yeah, wouldn't it be negative 1 because y on that is negative 1? Negative 5?
Y on this one?
Oh, negative 1.
Okay. Yep. Okay. Okay. All right. Here we go. This is everything, guys. This is what we've been waiting for. This is the lesson. Wait, it took us forever. Find the what? Oh, guess what that means? No. Guess what it means? It means no calculator. This is what you're going to be tested on. Okay. Find the exact value of the trigonomic functions. Ready? Here's quick steps for you. How do I do this? Well, let's sketch the graph first. Determine which quadrant we're in. So let's do that. Sketch that. This won't take you long. Just make a picture. Would you agree that I'm in the right ballpark? Yeah. Okay. All right. Now, number 2. Find the what? Well, what's the reference angle going to be? Oh, it's right here. It's 60. Well, I got to get a triangle, so I might as well go up, turn on the side, down to the x-axis, back to the origin. There it is. Okay. I'm telling you, I don't use the unit circle. I go with my special triangles. If that's a 60, what's this side? Square root of 3. That would mean this is a 30, by the way. What's this side? No? Yes. And then the hypotenuse is always going to make it, we're going to make it simple, 2. Right? Okay, what is sine? Okay, wait. Complete a right triangle with the nearest. Determine the function's value, positive or negative. Well, we'll figure that out later. Based on the sine of x and y, here's your x, here's your y, in that quadrant, determine whether the value, are we positive or are we negative? Well, let's see. First of all, sine is what over what? I agree. It's opposite of hypotenuse. It's y over. Isn't it y over r? Right?
Yeah.
Okay. Y is what? Square root of 3. R is what? 2. Oh, there it is. How come it's positive? It's because the y value is positive and the radius is always positive. Positive or positive. Okay, here's a quick way to remember this. Do you guys remember? Do you remember that quick saying? How to remember if things are positive?
All students take.
All what?
All students.
All students. All functions are positive here. Students, all students. Sine is always positive where? In quadrant 2. All students take. Okay, guess what the T stands for? Tangent's positive in quadrant 3. Take what? Calculus. Okay. Cosine is positive in quadrant 4. Okay, can I ask you this? Where's tangent negative? If tangent's positive here, and tangent's positive here, 2 and 4, tangent's negative. Where's sine negative?
3.
3 and 4. Okay, you got it. Okay, do that one. Tangent negative 225. First, you gotta draw it. Once you draw it, figure out your reference. Your reference is what? A what? A 45. Okay, good. So you have a 45, which means your legs are what? 1 and 1. Which one's negative though? The x value is negative. The radius will be what? 32. Okay, you know what we want? We want tangent. Tangent is what over what? It's y over x. Gotcha. Your y value is 1. Your x value is? Your answer is? Ah, the answer is negative 1. Yes, no, yes, sort of, kind of. Okay, the next 2 slides, I don't know this. I think those are the first slide that I skipped.
Yeah.
Go.
Yeah. No.
Okay.
No. It's not that one. It's not that one. It's none of them.
No, it's not that either.
It's
okay.
none of them.
So what about this? Do you have this?
No.
No? Okay. Okay. Well then, do yours. You have sine of 7 pi over 6, right?
Yeah.
Do it. Do it. I'll change mine. Sine of what?
7 pi over 6.
Okay. Guys, this is the same thing we just did. It's just radians, right? Figure it out. God, not it. Clock is almost through. Okay. Let's just go try it. I'm kind of going fast because I know the Belgian thing, but you went past 180 by how much? 30 degrees or pi over 6. So you know what? Put a 30 there. Call that 1 negative. That's a 60. Call that square root of 3 negative, and call that 2. Since we're doing sine, you got to remember, sine is y over r. What are you going to write? Say it, say it.
Negative 1 over 2.
Yeah. It's negative 1/2. Sine of 7 pi over 6 is negative 1/2. Sorry, we didn't make it. It's like 3 and 5. I treated you the same. Katie, are you just tired of that? Did you guys get a chance to put your assignments in the red folder? Katie just threw it on the floor. She was fed up with it.
You know,